he always impressed me with ability to work with databases and finding answers to questions and finding them very complex solutions. So I'm very happy that he took the challenge to come here and show us over 20 years of experience.
Yeah.
The EPICS was developed.
I'm a very impressive guy.
I think we can go through the room. ZY is the head of the beamline control.
Yes.
Oksana is in a group. Jun Ma in a control group, and we have a rep from the New York Structure Genomics. And maybe you can introduce yourself.
Sure. I'm Tomin, or Tomin.
We've been corresponding, about soft glue zinc.
Very nice to meet you.
Yeah, nice to meet you too.
And then Jili is also in beamline control group, and Tommy is in motion, I think. Yeah. Motion group.
Awesome. Okay, so you guys probably don't know me at all. I should probably start with who I am. I started out in nuclear physics at the University of North Carolina, and there was a Van de Graaff accelerator that was shared by 3 universities in that area, and it was run by grad students, and it was awesome. We tuned the beam, we made the ion source work, and we put it on target, and we did the data acquisition, and we did everything. And so I was effectively in beamline controls in the 1980s, but it was, it was low energy nuclear physics, it's a different system. And then I wanted to live with my wife, so I moved to Washington, and there's no nuclear physics in Washington. You have to do something else. So I switched to X-ray metrology, and I worked at NIST for a couple of years. And that was how I got connected to the APS, because at that time the APS was just coming up. And I got started at the APS as a postdoc, and then as staff in the nuclear resonance scattering group. And then EPICS happened. Marty Kramer went to Los Alamos, and you guys might know back in the 1980s there was this idea that Ronald Reagan's idea that we were going to put lasers in space and we were going to shoot stuff up. It was going to be great. And I think a lot of people thought that it wasn't really a very sound proposal, but it was a funded proposal, and scientists are not going to waste funding. It doesn't make any difference. And so what happened was they had a ground test accelerator that was to stand in for the accelerator in space, and there was a control system for that. It was called GTAX, and that was written by Bob D'Alessio and Jeff Hill and other people whose names you might not know. And Marty went down there for 6 months to learn about that and came back, and then he churned on it for a couple of years and turned out what we now regard as EPICS. And at that time, it was thought to be an accelerator control system, but there were some guys in the accelerator controls group who thought, your beamline should be looking at this. And at this time, we had no beamline controls group, because the assumption was that we would be running SPEC or SUPER or one of the other monolithic programs that ran entire beamlines back in the days of the Generation 2 synchrotron facilities. And that was never going to work, because beamlines are a lot more complicated now. You really do need a control system. It's not just one program anymore. And because I was always writing software and being involved in techie stuff and had hands-on, I started playing with it. And I went to Gopal Shenoy, who was then the division director, and I said, dude, because Gopal was the sort of a person that you could say dude to, even if he was your boss's boss's boss. It was great. He was a wonderful man. And I said, we need to look at this, because there's stuff here that we can use for beamline controls. Because the other problem that we had was all the second generation synchrotron facilities and all of the data acquisition that I had been involved with used KMAC. And it was clear by then that KMAC was not going to cut it. We were going to have to switch to a faster instrumentation bus, and it looked like VME was going to be the bus, and we had nothing. We had no controls group, we had no understanding of VME, and we needed to produce some beamline control software fairly quickly. And so I told Gopal that we have to look at this stuff, and he said, well, why don't you do it? And I said, no, I don't want to do it. I want somebody else to do it. And he said, look, if you want this thing to be done, you're just going to have to do it. So just make a group, hire some guys, and write beamline controls. And so I did that. And I thought I'd be doing that for a couple of years, And I remember telling Bill McDowell, who was then the accelerator controls group or the accelerator controls group leader at the APS, I said, I'm going to do this for a couple of years, then I'll go back to Sector 3, and I'll be doing nuclear resonance scattering, and he just laughed. I remember his face when he said, "That is never going to happen. You are going to be in beamline controls for the rest of your life." And he was right about that. And so I'm still in beamline controls. And I did form the group initially. I'm not the group leader anymore. And I'm not actually doing beamline controls anymore because a couple of years ago I switched. I started doing FPGAs for reasons I'll describe if I actually have to. I guess that was about 2 years ago. And that got me into metrology, which is where I wanted to be in the first place because metrology is awesome stuff. That was what I did the postdoc in NIST in. And now for the beamlines that are coming up at the APS, I'm sort of halfway involved in metrology and FPGAs, but I still do a lot of beamline control software because you can't get away from that stuff. It's a never-ending, well, you guys probably know this already, it's a never-ending struggle. All right, that's how I got here. Now I'm going to give Andrew Johnson's talk about EPICS because I don't know what you guys know about EPICS, so I'm starting from zero. And I don't mean to offend anybody by starting from zero. I just don't know what you know. So, and Andrew can't be here because he's under the gun because of the upgrade. So anyway, here's the outline of this talk. What's EPICS? History, I already gave you the history. What does it do? The community, and something about ecosystems. So EPICS is not a control system, right? EPICS is a toolkit that you can use to build a control system, and that's part of the reason why it's applicable for beamlines and also accelerators. There's not a lot of built-in specificity about what that system is going to do. It's very, very general. And it's mostly a software toolkit, and I'll go into some of the details. This is an old slide of all the facilities that are using EPICS, and there's no point in trying to keep track of this stuff. We stopped trying to keep track, I think, around 2011. But anyway, there's a bunch of labs that are doing it and contributing to it, including you guys. Thank you. There's a mailing list that you're probably already familiar with. There are yearly meetings or twice yearly meetings. And the point of EPICS is that it's client-server control system, distributed client-server control system. There's going to be a bunch of, this could be VME crates, or they could be just Linux servers, or they could be soft losing ARM processors. There's a whole bunch of stuff down here, and then up here are all the client-side applications. And the idea is that there isn't any limit to how much stuff you can put on either side of this network. EPICS has scaled to very, very large facilities, and also it scales down to a single laboratory, or which is basically a beamline. An X-ray beamline is sort of, it's more complicated than a lab. So I guess the fundamental unit of currency is the process variable, and EPICS gives, that is the connection between a client and a server. That's the only thing clients know about servers, typically, is that there's a process variable, they ask for it, and the server replies. And so there's some examples of process variables. And a process variable also has other attributes, and this is, which will be described actually later. But other things like the engineering units and the description of it and the limits on it and all that. So there are already a lot of client programs, and there's a lot of IOC software that you guys can look at. And some of it's going to be directly useful, and some of it's just going to be examples of what other people have done. But there's a whole bunch of stuff. I don't envy you the task of looking through everything that exists already and trying to figure out whether or not it's useful for anything that you want. So it consists of individual programs, code libraries, and one nice thing is that you can talk to EPICS from any programming language that I know of, anyway. Python is really popular on the beamlines, and Python's got great access. There's folks that use MATLAB, but of course you can do it with C and Java and all that. I don't think Yeah, I think I pretty much went through most of that. So right, until 2002, the IOC, the server part of it, only ran on VME crates, which was awkward. That was a wrenching change for a lot of people because there were a lot of things built into EPICS that were VxWorks specific. But since 3.14, EPICS runs on Linux and RTEMS, and as Andrew says, we have no recent records of who uses EPICS or for what. There's just no end to the people. I mean, they just crawling out of the woodwork. EPICS is very general. Morning. One of the things that was useful for us initially is that you can do closed loop, slow and fast closed loop control. That was one thing that we knew we were going to need, and you really can't do that with SPAC or another monolithic program. That was one of the reasons why we knew we had to have an actual control system, because you have to have closed loop control on these beamlines. I guess in the last 10 years, image data has become something that EPICS can handle. That was not true before Mark Rivers went and wrote area detector. So this is probably worth looking at for a little while. Some of these things can be done in both cases. Operational constraints can be applied at the server side or also at the client side. You can do closed loop control in a client, but typically it's done at a lower level. Access security, the thing that determines whether a person has access to a process variable is allowed to write to it, that happens in the IOC. There is some data trending and archiving here, but that's mostly a client-side feature. A lot of automated sequencing here, fast here and slow here typically. This is outdated. Control group leader Dennis, sorry about that. I didn't have access to this source because Andrew's on travel, so sorry about that. Nobody knows who's in charge of EPICS. I mean, everybody recognizes that Bob Alessio and Marty Kramer and Jeff Hill and Ralph Lang. And there's a number of guys who are sort of informally taking the lead in the area that they're interested in or good at. And so it's pretty organic. There's not like a lot of structure on top. It never has been that way. But it has evolved over the years to be a little bit more formal. Back in the olden days, you used to, at EPICS collaboration meetings, used to have arguments. People used to actually disagree about what they wanted to do. And now that's not so true anymore. Now it's more of there's only enough time to describe what you did, and it's almost an advertisement. There's not a lot of information in the talks because they're so short. What happens is you find out who's interested in what you're doing and you go talk to that guy later. That's how it typically works. And a lot of that's usually over email. So, Tech Talk mailing list. There also is a new EPICS site, epics-org, I think it is. But I think it's not quite ready yet. I think right now the place to go for information is still epics.anl.gov. I think that's, for the moment, that's the best place. Yeah, this is the old www.aps.anl. That's old. It's now epics.anl.gov. And this is what that website looks like. And because I forgot to give you I forgot to include a talk on the records that are in EPICS base, I'm probably going to just go there and show you where the documentation for those record types is. This is all out of date. But EPICS started with I mean, it's always used version control, but that has changed over the years. And now it's pretty much some combination of Jenkins and Travis for continuous integration. I'm not involved in, I don't know anything about that stuff. All of the stuff that I know about is on GitHub, and I'll talk about that later. All the Synapse stuff is on GitHub, and Area Detector is also on GitHub. So at the APS, it's mostly VME-based IOCs for both the accelerator and the beamlines, but increasingly soft IOCs are starting to show up on beamlines. And some stuff, I hate it, it's on Windows. I had to work on a Windows system. And it might be great if you know how to work on a Windows system, but I don't. And it's a nightmare if you don't know how to work on a system and you have to do it anyway. And that's, you know, that's life. What are you going to do?
Distinction between hard IOC is really VME IOC.
Yes.
Is that
Yeah, that's right. Yeah, a hard IOC is something that is connected directly to hardware. And so that's usually a VME crate, although later this week I'll show you about soft glue zinc, which is effectively, I don't know whether it's a hard IOC or a soft IOC. It's complicated. We mostly use MEDM. I understand you guys use CSS Boy here. It just doesn't matter. I mean, we translate all of our displays into CAQTDM and CSS Boy and EDM because we just don't care. You guys use whatever you want. So there's some sample MEDM displays, and I imagine everyone here has already seen a display of some kind, so I don't think I need to go into that. Beamline IOCs are mostly VME based. We used to use PC104. We don't do that anymore. I think soft glue zinc has basically taken over this was basically a way to get to FPGAs. That's essentially what that was. And BCDA engineers and Beamline staff can connect to most IOC consoles through dedicated terminal servers for diagnostic purposes. This is, to me, the best thing about EPICS is somebody can call me at 9 o'clock at night and have a problem on a Beamline, and I can get on my local workstation and VPN into APS and SSH into the Beamline, bring up my copy of the same user interface that they're looking at, and watch them do what they're doing that's going wrong, and just say, no, yeah, you missed a step. You need to do this here first. It's awesome. And it means that people are willing to call me at 9 o'clock at night because they know there's a good chance that I'm not going to have to drive in there. There's a good chance I'm going to be able to help them immediately. And that makes them more willing to call me, which is a good thing because you can't have a guy overnight waiting for somebody to come in at, well, 8, I guess. I come in at 10 in the morning, and then they've wasted the whole night because they missed something that was simple. So this is like the best thing about EPICS from my viewpoint.
you actually showed a live record. I've seen it in Area Detector and some other places, but we haven't used it here.
It requires some setup. You have to have a server, the live server, and I don't think it's all that well documented. Don Arms wrote all that stuff for us, and what I think we need to do, I mean, it is on GitHub. The module is on GitHub, but I'm not sure if there's enough information about how to set up a server, because what this thing does is actually pretty simple. When the Beamline boots up, it basically sends a message to a live server. It has this IP address, and that's the only communication between those two things. And it just sends it some information about who I am, what is my boot directory, what operating system am I running, all that kind of stuff. And there's also kind of an alive thing so that if that crate goes down, then eventually the alive server will find out, and you can go to a web page and find out which IOC is down. So
Can it provide like a version also of what is running?
it does give the software version of what's running. Yeah.
Okay, that's cool.
But for me, the most important thing is that it gives you the location of the boot directory, because we got like 60 experimental programs, then hundreds of IOCs, and they've all been Synapse 5.2, Synapse 5.4, 5.6, 5.7, 5.8, and it used to be what I would do was I would guess where the IOC directory was, and I would go there and I would look at the autosave directory and try to find how recent the files there were and figure out whether that was the running system. Now there's a script I can just type IOC go 4IDD, and I go straight to the directory because the Alive system knows where the home directory is. So that's really handy, especially if you're trying to provide support for somebody else's beamline. Well, we don't actually have ownership of beamlines, but sort of informally, each member of the beamline controls group is sort of primarily responsible or said to be the liaison to a particular beamline and knows everything about that beamline, but everybody has to work on all the beamlines because it's just inevitable. And part of the reason for that is that there are so many learning curves in beamline controls that you just can't be up all of them at once. And so typically there'll be one guy in a group who catches fire on one thing, like he's really good at motors or he really understands VME. And there'll be another guy who's really big on sequence programs or understands X-ray optics or whatever. And so the beamline liaison will do most of the stuff on the beamline, including all the grungy things like adding another 8 motors or adding a scaler or something like that. But then when something comes up that's in somebody else's area, that guy's going to get dragged in. As I'm sure you guys work the same way. This doesn't exist anymore. This was originally a way to display data, but it's been overtaken by events. And you guys have blue sky anyway, so I think that's not going to be very important. You know more about CSS than I do, I believe. I have used it, but it is kind of a different model than MEDM. And so, because MEDM is about ready to fall over because Motif it's based on Motif, and Motif is getting more and more iffy by the year. Our management decided that we were going to switch to something, and our users chose CIQ-TDM because it looks exactly the same as MEDM that they've been using for the last 20 years. And that's also good for us because most of the Synapse displays were intended to be run with MEDM. That's all we knew at the time. And and CIQ-TDM looks the same way. You bring up individual displays. It's not like there's one thing where you put all the displays the way it is in CSS Boy. So some of the displays are a little bit awkward, or at least in my experience are a little bit awkward. And that's partly because I don't know what I'm doing with CSS Boy. I just haven't had enough experience with it. I don't know what to say about these screenshots. CIQ-TDM, I think, is almost not even mentioned here. They all look the same, you know. It's not that. I don't know that much about EPICS version 4. I talked to the guys who were developing it a couple of years ago because I wanted to make sure that they understood what beamlines were up against. And part of the reason for version 4 is for beamlines because the version 4 is basically just a new channel access, at least in my opinion. It's a new channel access that's much better. And a lot of the things that we had trouble with early on are that with channel access, it's only one PV. There's no association of PVs. If you want the engineering units for a PV, okay, you can get that. But if you want an error bar on the PV value, it's got nothing. And if you want an image and the number of X pixels and the Y pixels and size and the type of the pixels, you got nothing. They are just collections of separate PVs, and it's the client's job to figure out what all goes together. V4 fixes that. And from my viewpoint, that's the reason for it. And my viewpoint is very, very narrow. I don't know that much about version 4. And so I'm not going to talk about it because you really need to get somebody who, and maybe you already have had somebody who understands version 4 talk about it. Oh, that's it. It's probably a good time for questions or comments or whatever you guys want to talk about.
So, channel finder, how do you find PVs?
I don't. I just know where they are. And I don't, okay, so the question is, how do you find PVs? And I guess I need you to elaborate, and I'm not really sure what you mean.
So what we are doing is we are actually, when the IOC starts, we are writing to an NFS mounted directory, and that is kind of information coded by the server name and stuff, and that's how we've been doing it on the beamlines. I think Accelerator moved to a different model now. There's a, I'm not sure what Kunal decided to do. But it's, the writing to a directory, there's always a lot of dead PVs that, you know, something was written and then the IOC was rewritten, it's a different name. So I know that on the Accelerator side, I think they had something like 3.5 million PVs, but when they went to a new active PVs, it actually went below the million. So
Wow.
that makes a big difference in terms of what is actually there.
We don't do that. To repeat the question, it's a problem if you have a list of PVs that was originally compiled somewhere and then some of those PVs go away. And it can be a big problem. It's not a problem for us because we don't keep a list of PVs. For us, all of the information about what PVs exist is contained in the MEDM displays that a user is going to run. And those are the only PVs that are in active use. We do have a listing in each IOC. We use DBL to list all of the records that are in the IOC. But we don't have any systematic search for those things because we don't want to know where they are, really. We know that the EPICS prefix describes which IOC a PV is in. And so for the beamline that we're interested in and for the station on that beamline that we're interested in, if we need a complete list of PVs, we'll just use DBL. Yeah.
Your live server that you mentioned, is this one server for sector, for beamline, for the whole facility?
One server for the APS.
For the whole facility? And
For the whole facility.
And who's maintaining it?
Don Arms maintains that.
It's from the control rooms or?
Don wrote it. He just up and wrote it, and everybody's like, wait a minute, what?
And he maintains it, okay.
Yeah,
Okay.
and it was kind of surprising. And actually, at the time, some of the people in management were like, don't waste your time on this. This is stupid. But for us, it's pretty useful to know which beamlines are in trouble is a good thing, although nobody really monitors that. But as I said, for me, it's mostly just how do you get to the IOC and know that it's the right one.
Does it replace for IOC, the need for IOC stats, for example?
No, it doesn't replace IOC stats because it's really a different purpose. IOC stats is a purely local thing that, you know, about if you're already on the IOC, how much memory do you have, if it's VxWorks, are you running out of network buffers, or, and there is some of that information in the Alive database, but mostly it's just about who's awake now and where is their source, where's their IOC application directory.
So how do you distribute the EPICS software in your facility? Is that actually always compiled on the local machine, or is that NFS mounted?
That's a good question. So how do we distribute software? We do it quite differently from the way you do it, I believe. We have one main server called APS Share, on which the beamline controls and other groups put everything, all the versions of Synapse and copies of the display managers, CAQTDM, and other runnable programs. And all of those things get rsynced out to dserv machines, and each sector has a dserv machine. So they have a read-only copy of all of that stuff, and they have a read-write area where the IOC directories are. So they're not pulling directly from APS Share. That happens at midnight or something like that, once a day. Everything from APS Share gets copied out to all the dservs. And management doesn't like that very much because it's more expensive than other ways. But it's a pretty handy way to do it for us because it's one place where we can distribute software, and it's not our choice about which software people use. Typically in a version of Synapse, we'll have more than one version of the autosave module, for example, or the scan or the motor or anything like that. When we put the first version of Synapse out on APS Share, it's all one, there's just one set of modules. But after that, as modules get upgraded, Beamlines can choose whether or not they want to use the new version of module or the old version of a module. And that's our only way of testing software, because I don't have a Beamline in my office, and nobody else does, and I don't even have the equipment that runs on a Beamline in my office. So if you want to test software, you have to get it on a Beamline, and that means you have to get it through the Beamline scientist who does not want to crash, right? And so for them, it's a choice of, I don't want anything to change, but I have to have this new version of autosave because I need to take advantage of a feature that's in there. All right, I will run that risk, and that there's a problem in that because there's something in it for me. And so that Beamline can by itself just choose, I want to run the more recent version of autosave, and then after they've been doing it for a while, then everybody else believes that it works, and it's not going to trash everything. So that's how we test software at the APS, and I guess you guys have sort of a similar mechanism that allows Beamlines to say, I don't know how it's arranged here. I want this version of EPICS, I want this version of Synapse, and I want these versions of all these modules. There has to be a mechanism for doing that.
So we've been doing a Debian packages, which actually gives you only one version, and we got into these kind of troubles that things didn't work, so we did the local patches, and we've kind of got ourselves into trouble that way. Because we are not very good in reporting we solve the problem and then we move on. And that was my experience with that, with the single version. And I've been looking into NFS as a method of distributing it globally to the Beamlines. But unfortunately, NFS here is very unstable. NFS here in this facility. I don't know why. It just goes down, up, and
All right, that's a problem.
it's really something internally that I don't quite understand.
But
you have not seen the NFS issues.
well, I mean, there's always going to be NFS issues, but not systematically. And autosave flat out doesn't work if you don't have NFS. And autosave for us is huge. So when there are NFS problems, there are loud outcries, and those problems generally get fixed.
But you have one NFS for global facility.
I don't know anything about it, actually. It just
but
works.
there is NFS, yeah. You
Right.
mean like APS Share is a global NFS?
Yes, it's
global for facility.
right, yeah. And IT does all of that stuff, and I look at it as plumbing. I pretty much am. Right? It's in the walls, and I don't know how it works. I don't see it, and I turn on, right? Which is the way Beamline scientists look at Beamline controls, or at least that's what I hope for them to do, is to look at this as plumbing that they now have to think about, right? So yeah, I got nothing.
And DServe is local to the sector?
A DServe is actually a virtual machine that through the network is made local, but all of the DServes are actually just little slots in some big machine. But I don't know how all the networking actually works, but each sector has one DServe, and some sectors have two, depending on whether they have to be separated or not.
Another question.
Yeah.
So all your EPICS libraries you build and run from source, is this correct?
All the live.
So you build from source a version certain and you use it on a Beamline, which is...
All the libraries are built from source, yes.
And-
I mean, we bring down EPICS, and then we bring Synapse and all the other modules that we
Yeah.
want, like DevOps Stats, and we build those on APS Share, and then that whole stuff, all that stuff gets rsynced out.
Yeah, so you should have kind of a shell script that loads the hashes where to find all this stuff, right? So you know what to look for the library. If you build a motor, while you build it, you should know somehow you shouldn't edit your release file every time that you build in. You can just load the general file which tells you where the libraries are. So my question is, do you have this like unique file that tells you the passes to where everything is located?
Yes, we do. So the question is, how do you maintain control over all the different versions of all the different modules that are in Beamline's software? And I'll show you that when I get to the Synapse talk, because we do that in Synapse. It's not something that's provided by EPICS.
Okay.
So should I continue on to this talk, or should we take a little
Could
break?
take
Or what
5
would you-
minutes break. But one more question. When you distribute the versions, do you keep sources together with the version on the APS share?
So the question is, when we distribute, do we keep the sources? Yes, we do. And actually, we even stupidly keep the intermediate files, the .o files and all of that, which is just really dumb. But we don't even clean. We build it on APS share, and so everything's there. And then if you need to look at the source to understand why you're having some kind of a problem, it's obvious how to do that. You know from your release file where that thing came, and you can go straight to that piece of software. So we don't use executables.
And the build would be just for Linux or also for Windows and
All the builds, well, not necessarily for Windows, but for Linux and for the various versions of VxWorks, for each architecture, actually. All those builds are on APS share and then get rsynced.
So maybe we take just 5 minutes break right now?
Yeah, that sounds good.